Okay, welcome to video 2 on parametric equations. In this video, we're going to look at the calculus of parametric equations. We're going to find the slope, we're going to find the second derivative, and we're going to find the length of a parametric curve. The formula for the derivative of a parametric curve is dy dx. And so to find that, we have to find the y component, the derivative of the y component with respect to t, divided by the derivative of the x component with respect to t, provided dx dt is not equal to 0. Now, to find the second derivative, you have to be a little bit more careful. It is the derivative with respect to t of the first derivative divided by dx dt. Once again, write these down, and you just need to know the formulas. So we're going to start by finding y prime and y and the second derivative of this function. So to find the first derivative, we have to find dy dt. So dy dt is simply cosine of t, because the derivative of 1 minus cosine t is positive sine t. The derivative with respect to x of the derivative with respect to t of x is cosine, negative cosine t. We could simplify this and say dy dx is negative tan t. That is the derivative with respect to x. That is the slope. Now, to find the derivative, we have to derivative of the first derivative divided by dx dt. So the derivative of tan is secant, negative secant squared. And the derivative of dx dt remains the same, negative cosine t. We can simplify that to be 1 over cosine to the third of t. I just moved the secant square down. Okay, once again, to find the derivative of y with respect to x, we start by finding dy dt, which in this case is simply 2, and then we find dx dt, which is 2t plus 3. To find the second derivative, I have to find the derivative of this first function, but dx dt remains the same. So to find the derivative of 2 over 2t plus 3, I'm just going to write that as 2 over 2t, 2 times 2t plus 3 raised to the negative 1. And that gives me negative 4, because I had to use chain rule, of 2t plus 3 squared over 2t plus 3. So we're going to find the equation of the tangent line. So to find the equation of the tangent line, we have to use the slope. So remember, the equation of the tangent line is y minus y1 equals m times x minus x1. That still works. So to find m, I have to find the derivative. Well, I'm starting by finding x, because what I've given you is t equals negative 1. So now I have to find the x and the y coordinates. So to find x, I replace t and x with negative 1. To find y, well, y is equal to t, so y is equal to negative 1. So I have the point negative 1, 1. Now, to find the derivative, I have to take the derivative of y, which is 1, and then the derivative of x with respect to t is negative 1 over t squared. My slope then at negative 1, I am replacing I'm replacing negative 1 into the slope formula, and that gives me negative 1. So now I have a point, I have a slope, I can write the equation on the line. Okay, to find horizontal and vertical tangents. Remember, a horizontal tangent occurs when the derivative is 0. A vertical tangent occurs when the derivative is undefined, or when the denominator of the derivative is 0. So everything goes back to finding the derivative. So to find the derivative of dy dx, I have to find the derivative of dy dt, which is 3t squared minus 3, and then the derivative of x is 2t minus 1. So I want to know, when is the derivative 0? because that'll give me my horizontal tangent. So I would set the derivative, the numerator, equal to 0, and I get t is plus or minus 1. Now, I need to go back and find the x and the y coordinates. So I have to take t equals 1 and replace x in that, and I get 1 minus 1 plus 1 is 1. And when t equals 1, y is equal to 1 minus 3, negative 2. And I would do the same thing for negative 1. So when t is negative 1, I'm trying to figure out why would that be 3. Oh, because I get 1 plus 1 plus 1. Okay. Now, to find the vertical tangent, I have to set the denominator equal to 0. And then once again, I take those values of t and find my x and my y coordinates. Graph the equations in parametric mode and find the points of intersection. So you can use Desmos or your calculator to find when they cross each other. And we see that it crosses each other at 2, 0, when x is 2 and y is 0. And then we can solve for t by replacing x with 2. We can find the derivative at this point by finding the derivative of the function. Again, doing dy dt over dx dt, and then replace those values of t into the equation. And they said find the equation of the tangent line here. So using the points 2, 0, using the point 2, 0 and the slope 2 over pi, I was able to write the equation on the line. To see when the interval is concave up or concave down, once again, we look at the second derivative. So to find the first derivative is dy dt over dx dt. I think we can clean that up a little bit. Now to find the second derivative, I take that value and I take the derivative of 1 plus 3/2 t and divide it by dx dt. So where's the second derivative? 0 or undefined at t equals 0. So using that, I can do a sign chart for my values, my second derivative. So I'm putting these numbers back into the second derivative. And I see that it's negative from negative infinity to 0 and it's positive from 0 to infinity. So it changes concavity at t equals 0. Okay, last thing for today is the length of a parametric equation. Now this is going to come in again tomorrow when we talk about the motion, modeling motion using parametrics. So the length of the curve is the same as the total distance traveled. And to find the length of that curve, it's simply the derivative of x, your x component, the derivative of your x component squared, and the derivative of the square of the y component. I think that I'm saying that right. And here's an example. We have the parametric equation, e t to the cosine t and e to the t sine t. I need to find dx dt, and I need to find dy dt, and I'm going to have to use product rule. So using product rule, I was able to find dx dt and dy dt, and I'm just going to put both of those into the equation. Generally, for parametric equations on the exam, it is calculator active. Not all the time, but most of the time it's calculator active. If it's not calculator active on something like this, they would just say, write the integral, show the integral. They wouldn't expect you to do this without a calculator. And again, remember to round to 3 places behind the decimal. Okay, so Mae Jameson, did you know that March is Women History Month, National Women's History Month? So I thought we'd end today with a quote by a woman, and yes, she's African American, because it's always African American month for me. So never let anyone rob you of your imagination, your creativity, or your curiosity. Go on and do all you can with it and make it the life you want to live. I think that's very good advice. Have a great day.